Hello, this is a video tutorial for Titan-5-3M cam. We're going to be programming that part. So first you're going to go to your data panel and you're going to navigate to your instructor's project. You'll right click on the model and copy it to your own folder. In my case it's a demo folder or project. And select copy. Okay, and then you can go back and navigate to your folder and it should appear in there. So let's double click on that model to open it, and we're going to close the data panel so we get more space. And it's this star shape with a series of holes around it. Okay, so we're first going to go switch to manufacture mode. And as usual, we're going to create a new setup. We're going to go to have this setups highlighted. We're going to go setup, new setup, and we're going to set up our stock. Now this is probably the first project you've done where you set up stock on a circular part. So in this part, our overall diameter is 1.95. So we have 50 thousandths of extra material per total. So we're going to put 0.025 as our side offset, and we should have an X width of 2 inches by 2 inches, and we have 0.4 that we're going to move off the top, and we have a overall thickness that we're starting with of 1 inch. So we need to put that difference on the stock bottom offset. So that's going to be 0.21. So it should give us a 2 inch by 2 inch by 1 inch piece of material. Now the direction that is saw cut, you're going to want to have in the direction facing so that it's not the faces you clamp against. 2 of the faces will be mill cold rolled from the aluminum mill, and then the other 2 faces that have the saw cuts might vary in length, so it might be a little more than 2 inches. Okay, so now we're going to go to setup. At this point, if your x-axis and y is as shown here, we're just going to go and pick a stock box point of this corner for your first operation. Okay, and you may need to flip it, and if you have trouble with that, you cycle through these different options here. Okay, since we've done that several times, I'm just going to move on to the next tab, which is our post-process tab. And we're going to call this 1041. Our program comment is going to be operation 1 with a work coordinate system of 1. Okay, we'll select OK, and our first setup is created there. Okay, now we're going to do our first operation, and as usual, it's going to be a face mill. So we're going to come in here and we're going to face this thing, and we're going to select from our Titan building blocks library tool 1, which is our 3-inch face mill. We're going to go 4,000 RPM. And I'm going to start having you go a little bit faster. So we're going to go 40 inches a minute here, 40 inches a minute, 40 inches a minute, 40 inches a minute, 40 inches a minute. Okay, we're going to go on to the next tab, which is geometry. There's really nothing to select here. We're going to go to our heights, default, 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 default. So we should be cutting off 40 thousandths worth of the material, which is between the cyan plane and the dark blue plane. Okay, we're going to move on to passes. 4 thousandths tolerance is fine. Pass direction. We're actually going to go 90 on this, and our pass extension is going to be 1.6. And we're going to leave the stock offset alone and step over alone. And what we want to do is, since this is doing one single cut, we want the direction of cut to go against the fixed jaw of the vise, especially with this small of a piece. If we go from side to side. So if we set this at 90, I believe it will go in the y-axis, and ideally we want it to go from the operator away and move the table towards the operator, but the cut will go away from the operator, pushing it against the fixed jaw. I'm going to go ahead and hit OK and see if those parameters work. Okay, they did not. It's coming down and coming out. So the way you change that, we're going to go to Edit, and we're back at our Passes tab. You switch this box, it says from the other side, and what it'll do is it'll come from the opposite side of the part and reverse the cut. Okay, so we don't want multiple depths. We don't want stock to leave. And then we're going to move on to the next tab, which is linking. We're going to leave all these first ones at default. Lead in, we're not going to have a vertical radius, so we're going to set that at 0. And we're going to leave these others at default. And select OK. So now the face mill comes straight down, and then it feeds towards the fixed jaw of the vise. Okay, because we selected that box on the prior tabs. Okay, we're done with that. We're going to move on, and we're going to do a 2D adaptive clearing on this. Alright, so for our 2D adaptive clearing, we're going to use the 1/2 inch end mill. And it's probably not going to be able to cut these radiuses here. So we're going to be coming back in with a finish cutter, which is the 3/8 to clean all that up anyway. So we're going to go 2D, adaptive clearing. You're going to select the Titan library, 1/2 inch end mill. Okay, with a 1/2 inch end mill, we're going to go 4,000 RPM. And we're going to go to cutting feed rate of 25 inches a minute, 25 inches a minute, 25 inches a minute, 13 and 13. Okay. And we're going to go to geometry. Our pocket selections are going to be here and here. And our stock contours, we're just going to leave that at default. It's what the box of the stock is, the 2 inch by 2 inch square. So we're going to move on to heights. We're going to leave all that at default. We're going to change this to model top because we've already cleared off the top of the part. And our top height is also going to be at model top. Our bottom heights are going to be at selected contours. So it depends on which contour we selected. We're going to go to passes. Our tolerance at 4 thousandths is fine because this is a rough cut. Optimal and load 0.2, we'll leave that alone. We want a minimum cutting radius of, that's fine, 0.05. It's going to cut as much as it can. And we're going to climb cut, and we're going to do multiple depths. And our maximum step down is going to be 5. Okay. We're going to do order by depth. And we're going to leave 20 thousandths of stock to be removed by the next cutter. We're going to select smoothing and leave 4 tenths tolerance. The next tab, we're going to leave all these at default, including the non-engagement feed rate. So when it doesn't pull up to the rapid plane, it'll go 25 inches a minute. We're going to do horizontal lead-in radius of 0.1. I don't think we need a vertical lead-in radius. Ramp type's going to be helix, 2 degrees. Ramp taper angle, leave it alone. Ramp clearance height, 0.1. Helical ramp diameter, let's set this at 0.3, a little bit smaller. And we don't worry about entry positions, at least at the moment. Let's hit OK and see what we get. So we get this kind of, looks kind of crazy, but yeah, it roughs here, and does 2 rough cuts for the cylinder. But it pretty much roughed the star out pretty well. We're going to go 2D. No, we're going to go 2D contour. We're going to select the 3/8 diameter tool. So that's tool number 3 in the Titan library. We're going to go 4,000 RPM. Again, 25 on all these feed rates, with half of that on the plunge. Okay, we're going to go to geometry, and we're going to select just the star. Make sure the arrow's on the outside. We're going to go to heights, and we're going to go model top on retract height and model top on top height. Okay. And we're going to go to a depth of the contour we selected. Okay, so we have 4 tenths tolerance. It's fine. Left, we're climb cutting. We're going to switch from in computer to wear, and our compensation radius we're going to leave alone. We're going to skip down here. Our finishing feed rate is going to stay at 25 inches a minute. We're going to come down here and select the rough passes. So our finishing step over box appears, and we're going to put 0.01 in that box. And so we're going to get 1 roughing pass on the sides. Our roughing pass maximum step over is going to be 0.2. The reason for this is being smaller is as we don't have a lot of material to remove, but the distance between this arc and this circle is more than the diameter of our cutter. 4 thousandths smoothing deviation is fine for the roughing. We're going to do 2 step overs. We're not going to do multiple step downs just because we've already cleared most of this material out of the way. We're going to go to smoothing and select that for our finish pass. Now we're going to move on to the linking tab. Okay, so we have 1 rough cut, a second rough cut, and then a finish cut. It's going to finish the sides here. It's like a little clover leaf. Okay, now we're gonna cut the bottom profile with the same end mill. Okay, so we're gonna go to 2D. We're gonna do 2D contour. We're gonna select the bottom circle, and we've kept the same tool, so all the numbers will be the same on the tool tab. We've selected the circle on the bottom. We've checked that our arrow's on the correct side of the line. And then we're going to move on to heights. This is going to be model top. Our top height, we're going to change that to selection. Our top height is actually going to be the top of that deck, because we've already machined all the way down. But that means our clearances for feed, our feed height needs to go higher. So our feed height is not going to be at the top height. We're going to go instead of top height, we're going to go to model top. And that way we make sure everything feeds down from model top to this plane. Okay, we're going to move on to passes. Okay, we're going to leave it in computer. We're going to change that to where. We're going to skip all these boxes until we get down to roughing passes. Okay, we're going to do a maximum step over of 0.3, and we're going to have a smoothing deviation of 4 thousandths is fine with 1 step over. We're going to come back up to our finishing step over and put 0.01 there. That box appeared as soon as we checked the roughing passes. 25 inches a minute's fine. Okay, we're going to do multiple depths. We're going to do a maximum depth of 0.25, and we're going to do one finishing step down, and that finishing step down is going to be 0.01. It's a long wall. We're going to finish only at final depth, and we're going to use even step downs. I'm going to minimize roughing passes so we can see the rest of this. There aren't any islands, so we'll go ahead and deselect that. And then we're going to hide multiple depths so that we can select smoothing, 4/10. Moving on to the linking tab. Lead-in's fine. Horizontal lead-in radius we're going to set at 0.1. 0.1 for our linear lead-in distance. 90 degrees is fine. We're not going to do a vertical lead-in on this, so we're going to set that at 0. Lead-in and lead-out's the same. We're not going to ramp in. We are going to put an entry position like in line with this hole here. So this will be our entry position. We're going to hit OK. Alright, so we come in, we arc in, we go around 2 rough cuts at 2 different heights and then a finish cut. Alright, moving on. Here we go. We're going to do our all our chamfering and then we'll spot drill. So we'll go to 2D chamfer, 2D chamfer, and we're going to do the star separately from this circle. So we got to select our tool, which is going to be our 1/4 inch chamfer mill, tool number 15. Okay, 4,000 RPM, 4,000 RPM, 20 inches a minute, 20 inches a minute, 20 inches a minute, 10 and 10 for ramp and plunge rate. Okay, pretty much half. We go to geometry. We're going to select the bottom arrow here, or bottom profile here. The reason we're doing that is we want this round to come out correctly. If we pick the top one, it may not, especially if the top ends up being sharp. Our arrow's on the correct side of the star. We're going to go to our heights. It's going to be model top for retract height. Our top height is going to be model top. And our bottom height is actually going to be model top. And then we're going to go to our heights tab, or I'm sorry, our passes tab. Our compensation is going to switch to where. We're going to leave these others at default. Our chamfer width is 0.01, it's 10 thousandths chamfer. And our chamfer offset, we're going to leave it on this one at default, which is 0.04. And we're not going to put a chamfer clearance, put 0. We're going to select smoothing, 4/10 tolerance. Now we go to the linking tab, leave this off all at default. We're going to have a horizontal lead-in radius of 0.1. 90 degrees is fine. Our linear lead-in distance is going to be the same, 0.1. And it's going to come in perpendicular, and we're not going to put in a vertical lead-in. Okay, where lead in and lead out are going to be the same. We're going to select OK. And we have our first chamfer mill. Okay. So to do the chamfer on the circle, we have to be careful because the chamfer mill, we don't want the shank to run into these edges of the stars. we're going to copy. We're going to right click on here and we're going to duplicate the chamfer mill that we use for the top. We're going to need to change quite a few parameters. First thing we want to do is we need to find out how much room we have here for our chamfer mill to overhang without rubbing against the star. So we're going to go up to inspect and we're going to measure the distance between that radius and this edge here. And the distance is 0.024, so we have 24 thousandths, which isn't a whole lot. So we need to make sure the chamfer mill is cutting on its outside edge, leaving enough distance to just barely clear this chamfer and not rub this feature. So we're going to close that, and we're going to edit this toolpath. So our RPMs and stuff are fine. That's the same as the last routine we did. We're going to go to geometry and we're going to clear the geometry selection because we're going to select something new. We're going to select this circle. And then we're going to move on to the heights tab. This is going to get a little tricky. So we're cutting down here, but we want to make sure that we're clear of our part when we're moving around. So our retract height is going to be based off model top. Our feed height is also going to be based off model top. Or I'm sorry, it's going to be model top. Okay. Our top height of our cut is actually at this plane here. So we're going to do selection and we're going to select this plane here. Okay, so that's the top of our cut. The bottom height of our cut is going to be also that plane. So we're going to select that same plane and our arrows go away. What's going to happen is our chamfer is going to be made not based off these heights, but based off the overrides on the next tab. So we're going to go to passes, and we have a 4/10 tolerance. Now, I discovered the first time I programmed this that even if the math factors out, the collision detection and fusion, if you're using compensation, requires a lead-in. If you require the lead-in, its collision thinks it's going to hit these, even though the numbers we put in are mathematically correct. So we have to disable where and just put it in computer. So we're not going to be able to compensate with the G41 line, but we can still adjust this cutter in Z to change the chamfer width. Our chamfer width is 10 thousandths, and our chamfer offset needs to add up to 125, which is half the diameter of the cutter, minus this amount, plus an amount that will not hit this. So how we're going to calculate that is we're going to get our handy dandy calculator out, drag that onto the screen here. So if we are using a 1/4 inch chamfer mill, half the diameter is 0.25. We're going to divide that by half, which gives us 0.125. We're going to subtract our chamfer width, 0.01. Okay, so that's the amount that would hang off the part if we just cut it with the very tip of the cutter. We have 0.24 clearance between here and here. So we're going to subtract 0.024, and that results with 0.091. So our chamfer offset has to be a minimum of that to not rub on this this feature. So we're going to go larger than that. we're going to put in 0.11. We're going to give it more clearance than it's needed. These two values have to add up to less than the radius of the cutter. So as long as that's 0.125 or smaller total, we're good. So we're at 0.12, which leaves 5/1000ths of diameter overhang of our chamfer mill. We'll have smoothing selected, and then we go to the linking tab and we leave these at default, and our leads and transitions, we have those deselected. Okay, and we're going to go choose an entry point of a spot in the front. So we got x-axis going this way. We're going to put it somewhat in line with this hole so the operator can see what's going on when this comes in. Okay, we're going to hit OK. And there we go. Actually, let's look at this in the right view. So we can see the chamfer mill coming around when we simulate. So we're going to simulate just that one tool path with in this case, we're going to have the stock turned off so we can see what's going on. So we got our chamfer mill coming around. Okay, so as it comes around, I'm going to pause the simulation. And as you can see, we have clearance all the way around. So that's only about 5/1000ths. It's going to cut on the very top of the chamfer mill. So again, we've offset that by almost the entire diameter of the cutter, less about 5/1000ths. Now we're going to move on to pilot drilling these holes. And we need to measure the diameter of this chamfer. This chamfer diameter is 0.265. So we need to go to a depth that's deeper than, or is half of that diameter to achieve that chamfer or countersink. So we're going to go here. We're going to go to drilling. And we measured this at larger than 1/4 of an inch. So we have to go in with a larger chamfer mill. So we're going to go to select. And we're going to go use the 3/8 chamfer mill. Okay, and it's 4,000 RPM, and 10, we're going to still go 10, even though it's bigger in diameter. And our geometry is going to be one of those faces of the countersink. And we're going to select all the same diameters. We're going to move on to heights. Our retract height is going to be faced off model top. Our feed height is also going to be based off model top. And then our top height of our operation is going to be whole top, which is fine. But our whole bottom is going to be based off whole top and a punched in value. So we're going to put in a negative offset of half of 0.265, which is 0.1325. And that has to be a negative number. Okay, so we get our chamfers, or our countersink going in. We're going to move on to cycles, and we're going to counterbore so that we can put in a 1 second dwell at the bottom. Okay, we're going to hit OK. And we got our routine. Now we're going to go on to drilling. Now the holes in this part are 1/4 holes. So we need to go in and we're going to go to drilling. We're going to do our pilot or tap drill size. We're going to go to Titan building blocks. And we're going to go to our 2283 drill. It's tool number 9. And we're going to go 4,000 RPMs fine, 16 inches a minute's fine, and 16 inches a minute for retract. We're going to select our holes, and we're going to go to geometry, and we're going to select one of the cylinders for our holes. And then we're going to select all the ones that are the same diameter. And then we're going to go to heights. We're going to have model top for retract height and feed height. Our top height is going to be selection, because we're going to select this plane for the top of the hole. That accounts for the chamfer. Our bottom height is going to be the bottom hole, but we're going to have the drill bit go deeper. Okay, so it makes the hole at the full depth that the model is designed. We're going to go to cycle, and we're going to do a deep drilling cycle, or peck drill. Okay, our peck depth, we're going to set that at 0.05 is fine, and we're not going to deal with any of the other parameters. We're going to select OK, and we're done with our deep drilling. Okay, so we've done our drilling, and something I noticed about the design of this part, we're going to look at how deep our drill went. So our drill bit has gone almost all the way through the part, and the way they've designed this, the threaded hole is shallow enough that we aren't going to get the full 275 thousandths of thread. There's just not enough clearance in a hole that is 300 thousandths deep to get a 1/4-20 thread all the way through there, unless we were to go all the way through the part. So what we're going to do is we'll go ahead and program the tap, but we're going to leave the amount of material between the difference of the two holes, and we're just going to live with the number of threads we have. So especially with a roll tap, they don't do well with going all the way through material. They tend to work better in a blind hole. So what we're going to do here is we're going to go drilling, and we're going to select our 1/4-20 tap from the Titan library, which is it says here quarters, tool number 12. Because it's a roll tap, we're going to leave that at 500 RPM. And on geometry, we're going to select one of our holes, and we're going to select all the same diameter so it gets the rest of them. And then we'll move on to heights, and our retract height is going to be at model top. Top height is selection. We're going to select that plane. The feed height needs to be at model top, and then that way these two planes, all our rapid moves will be above the star. And then we're going to go to we're going to go from that same selected plane down negative 0.275. Alright, so after doing that, we're going to go to cycle, and we're going to make sure we're on right hand tapping, and we're going to select OK, and we should have our threads. Alright, so that is it for the majority of the part, and now is the time to do some engraving. So I'm going to show you how to flip between model and manufacture mode and update your model. So we want to save all this, make sure that we don't lose any of this. And you're going to go to model mode, and we're going to create a new sketch, and we're going to put it on this face. And you can do what you like here. I'm going to sketch my initials, so I'm just going to use text, but you could just draw lines or a logo if you like. But to get full credit, you have to engrave something on there. So I'm going to use text. I'm going to place my text here. And I'm going to use a capital T and capital F. Now you notice it's upside down. That's alright. I'm going to just rotate it like this. And then I'm going to grab it and I'm going to center it. Okay. Now I'm not going to use that font though. I'm going to go to our fonts. So I'm going to select this font called CDM-SHX, which is a single line font. For such a small feature, it'll be easier to engrave. So I'm going to move that over to a little bit to the left. And I'm going to select OK. And then we're going to select on that text and right click on it. So right now it's text. You can change it if you double click on it, but we can't machine that. What we can machine is exploded text, which becomes geometry. So we're going to explode this text, and now it's literally just lines. You won't be able to go in and type in a change. You could draw it on there. So I'm going to say stop sketch, and then I'm going to save. And then we're going to go back to manufacture mode. And you're going to get all these warnings, which is fine. What it's telling you is, hey, this model's changed. So you're going to highlight the setup, and you're going to right click, and you're going to select generate. Provided nothing was deleted in the model, all your toolpath you already did will be regenerated when you do that. Good time to save. And now we're going to do a 2D trace command. Okay, and I'm going to select the 1/4 inch chamfer mill that we've been using for that. And we're going to go 4,000 RPM, and the 20 and 20 is pretty good for engraving. Okay, our curve selections are going to be this one, this one, this one, this one, and this one. Okay. Then we're going to go to our settings here. Our retract height is going to be at model top. Our feed height is going to be at model top. And then we're going to move on to our passes. So in our passes tab, we're going to have 4/10 tolerance. Pass extension we're going to leave alone. We're going to have a sideways compensation of center, so none of that. Repeat passes, preserve order in both ways. We can leave those deselected. Maximum angle is 90 degrees is fine. We're doing an axial offset of -0.007. So our sketch sits right on top of this surface, and we're going to engrave 7/1000 into the material. We don't need axial offset passes. We don't need multiples. And the up-down milling, I don't care. Don't care. I like that. And then we're going to deselect chamfer if it's selected, and deselect stock to leave. We do want the smoothing on. We want nice clean moves. If you have a curve on yours and it's small lettering, it's going to affect it. In the case of mine, they're all line segments, so it may not make any difference. But if you had like a letter C, letter O, 0, circular thing, that'll make sure there are facets in it. Okay, and then we're going to move on to the linking tab. And we don't want leads ins and lead outs. We want the plunge straight down. We're going to select OK. So there's our engraving that should have machined 7/1000 into the workpiece. Now, because it's into the model, you can't tell with the model displayed in shaded mode. So what we're going to do is we're going to switch the visual style temporarily to just a wireframe. And what that's going to do is it's going to allow us to see inside the model. And you can see our green geometry with our blue toolpath cutting into the model, and they're plunges straight down. So that should work pretty well. And we'll return to shaded mode here by picking down here at the bottom, going to visual style, and we typically want shaded with visible edges only. I'll have to adjust it down on the machine a little bit when it gets to this engraving, and it's at the very end of our program, so that should be fine. For that reason, we're not going to reorder the chamfer mill to be in line with these other ones. We're going to make sure to get the majority of the part done, and then we can mess with the engraving at the end. Okay, so that concludes the programming of the first side of this part. And for the second side, we're going to hold this in a soft jaw, which holds onto the diameter of the part and holds it so we can mill off the back. So we're going to create a new setup. And we're going to flip the part in the orientation we're really going to be looking at it in. Okay. So let's set our stock. Our stock is still going to have a side offset of 0.025. Our top offset, stock offset, is going to be 0.21. Okay, and then our bottom offset will be 0. So this should reflect the 4 thousandths we took off the top. In our post-process tab, we're going to call this 42, or operation 2 with a work coordinate system of 1. And now we need to set our origin. So where we want our origin is on this part, we're going to set it up. We need to flip our orientation. So we're going to go z-axis plane and x-axis. So we actually are going to set our origin this time on the bottom of our part. So we got our z-axis origin, but we're going to flip the z-axis. Okay. And then we're going to, our x-axis should be in the correct orientation already. And then we are going to select a model box point, which is going to be right here. Now if it doesn't let you select it, it's because that's where the origin was when the part was modeled. So you're just going to toggle this and go to model origin. So that puts our origin on the bottom of the part right in the center. So what we're going to do is we're going to indicate off the center of the soft jaw and the bottom floor of the soft jaw for our reference, because we don't have anything else to reference the Z height like we do with parallels. And we're going to select OK. Now we're going to go to 2D and we're going to do a 2D pocket, and we're going to select our half-inch end mill. So you're going to go to the Titan library, you're going to get the half-inch flat, 4,000 RPM. We're going to go 25, 25, 25, 13, 13. Then we're going to go to geometry and we're going to select this as our pocket. We're going to flip the arrow to the inside. We're going to go to heights and we're going to set that at stock top is fine, top height is fine, stock top is fine, and our selected contour is going to be the bottom. So all of these stay at default. We go on to passes. 4 thousandths tolerance is fine. Climb cut's fine. We are going to skip, we're going to go down to maximum step over. It's going to be 0.4, not 0.04. And we'll keep the deviation alone. This is really doesn't matter because the side pockets. Multiple depths, 0.125 step downs, one finish pass. We're going to leave 0.02 for that finish pass. Wall taper angle 0. We're going to use even step downs, and we're going to leave those other two at default. Our stock to leave is going to be 0 on axial, but we're going to go negative 0.24 on the diameter so that we can overcut the shape with the end mill. Make sure we cut all the full clearance. Alright, so we're going to go on to the next tab, which is linking. Leave all these at default. We're going to do lead-in entry. Sure, we're going to do 0.1. We're going to do a 90-degree sweep angle's fine. We're going to do 0.1 on our linear. And we're going to have lead in and lead out. That's the same. Our ramp type is going to be helix. We'll leave that at default. Ramp height's fine. Ramp radial clearance, we're not going to worry about that. And we'll leave those alone. That's fine. 0.475. And we'll hit OK. Alright, so we've got a pretty good spiral in shape and spiraling out. And the center of our cutter should come to about here. So the 3/8 that cut from the other side should have no problem breaking through there at the end. Alright, and that concludes the tutorial for Titan-5-3M.